looking at problem 6, which is a word problem, and we're going to try and solve this using our attack strategy of UPSCheck, and that's understand, plan, solve, and then check at the end. So our problem reads, a scenic train ride has one price for adults and one price for children. One family of 2 adults and of 2 children pays $62 for the train ride. Another family of 1 adult and 4 children pays $70. Which system of linear equations can you use to find the price x for an adult and the price y for a child? So let's try and understand what this problem is actually asking us to do. So if we didn't have our A, B, C, D answers down here for our multiple choice, it might be a little confusing because we've seen problems similar to this where we not only have to set up our system of equations, but also solve for our x and y variables to figure out, for example, how much an adult ticket would be and a child ticket would be. But all this problem is asking is for us to set up that linear system of equations. We don't have to do that extra work to solve the equations. So now we understand what this problem is asking of us. So we can start to plan out how we're going to set up those systems of equations. So I'm going to reread this problem one more time, and while doing so, we're going to mark down key and important information. So a scenic train ride has one price for adults and one price for children. Okay. And again, at the end of the problem, we know that x is for adults and y is for children. So those are going to be 2 different prices. One family of 2 adults and of 2 children pays $62. So that information right there, that's going to be very important. So how that reads, since it's all in one sentence, that kind of seems like, to me, that could be a potential equation right there. Another family of 1 adult and 4 children pays $70. And again, to me, that reads like that could be our second equation. Which system of linear equations can you use to find the price x for an adult and the price y for a child? And the problem gives us our variable, so that's also important to keep note of. So I'm going to write out what I underlined. That way we don't have to worry about trying to juggle all this extra information in the word problem. We just have the information that we need right in front of us. So we know for equation potentially 1, so I'm going to write equation 1 question mark. We have 2 adults and 2 kids for $62. And then equation 2 question mark, we have 1 adult and 4 kids for $70, just 70 even. Okay, so now, and one last step, I almost forgot about this one. I'm gonna mark adult is X and kids or children is Y. So that's our variables. So now we have our information that we underlined organized in front of us. We kind of already have this plan of, hey, these kind of look like they could be easily turned into equations. We just have to figure out what kind of operations are going to go in here. So for equation 1, we have 2 adults and 2 children. So that would total 4 people. So we're going to be adding these. Now that's a little confusing since 2 times 2 is also 4, but think of it as if we had 3 adults and 3 kids. We wouldn't then have 9 people. That would be 3 and 3. That would give us 6. So we know we're going to add these, and this would be part of our solving step. I forgot to say that. So we know 2x, so that's our 2 adults, since x is for adults, plus our 2y, that's our 2 kids, equals, so because it totals or pays $62. And then for our second family, they have 1 adult. So that's just x. We could write a 1 in front of here, but it's not necessary. But if you choose to do so, there's nothing wrong with that. Plus 4y, that's our 4 kids or 4 children of the second family. And they pay $70. And again, that's 1 adult and 4 kids, so that would make 5 people total, which makes sense since we have 1 plus 4. So now we've solved what this problem is fully asking. We've done that. So now we can check this just to make sure that we didn't miss anything. So let's reread the problem quickly one more time. Scenic train ride has 1 price for adults and 1 price for children. We know that because adults are X and children are Y. That's given. 1 family of 2 adults, that would be 2X, and 2 children, that would be 2Y, pays $62 for the train ride. Another family of 1 adult, that would be 1X, plus 4 children, that would be 4Y, pays $70. And I'm going to make sure that this doesn't look like 170. That's still a dollar sign. It pays $70. So now we've checked our answer. So now we just have to figure out what answer or what letter this answer corresponds to. So 2x plus 2y equals 70. We know that's not right. X plus y equals 62. We know that's definitely not right. We don't have any 2's in that first equation. 2x plus 2y equals 62. That one might be right. So I'm going to star C. We can come back to that one. 2x plus 2y equals 62. Again, that one might be right. So now we're down to C and D. So 4x plus y equals 70. That's different from what we have. D reads x plus 4y equals 70. So we can be pretty sure it's going to be D. Now let's just make sure it won't be C. So 4x plus y, that would be like 4 adults and 1 child. So we know for sure our final answer is going to be D. So now for any word problem like this, we're able to easily break it down, organize our information, know what the problem is asking, and then solve it using our understanding, plan, solve, and check strategy. UPSCheck. Thanks everybody, and good luck with the rest of your problems.